Hi, good evening, everyone. Welcome to our first class. In fact, not the first class, but yeah, good evening. Good evening, Surya. Right, good evening. Now we'll start. We'll not wait for others because we have to stick to timelines. And yeah, so first thing, see, Indian space program, we will do elaborately. We'll start with the basics. So it's not that today we are going to complete Indian space program. That's not the case. We will look at the basics and we'll ask some questions and understand how you have understood that concept. Depending on that, we will go ahead. So going ahead, let's see. Right. Yeah. So try to interact as much as possible. So depending on that, we will see. I want to understand how much you know. And if you have any doubt at the end, you can ask me because in between the flow may get stopped. Depending on that, we will see. Right. Now, first point which we have to look here is this is our beautiful Earth, planet Earth. Throughout it, the Earth, various kinds. See, what is space program about? What is space program, whether it is Indian space program or whether it is USA space program, it will launch satellites into orbit around the Earth. It will launch satellites in orbits around Earth. Okay, all the things we will discuss in detail. What is a satellite, what is a orbit, all these things. So basically, the things which we are launching into the space around it, these are called as satellites. Satellites will be rotating around the Earth in a fixed orbit. This orbit may not be circular. Okay, so all these dot things which you are seeing are varieties of orbits which we have. So if you observe, depending on the distance from the surface of the Earth, some distances are there up to low Earth orbit, 160 kilometers, medium Earth orbit, 2000 kilometers, above 2000 kilometers. So low Earth, this is all low orbits. Orbit is a path. What is an orbit? Orbit is a path around the Earth in which orbit is a path around the Earth in which satellite revolves. Yes or no? So varieties of orbits are there. Anything is an orbit. This can be an orbit. In fact, circular orbit. This can be an orbit here, like that. Many orbits will be there. Of course, they are circular. Don't get by my drawing skills here. Circular orbit. Varieties of orbits. All these dots are various things. It's not that a circle will be there. We are drawing the circle for our understanding. So varieties of things are being launched. Various kinds of satellites, they are launched, and varieties of applications we are using through these satellites, mobile phones, direct to home satellite linkages, and telemedicine, natural resources exploration, like that. Many applications are there. We will see those applications in detail. Don't worry. But observe the figure. This is one such hypothetical figure taking the actual snapshot. What is happening here is, if you see, there are many white dots, many satellites are there in low orbit. As the name says, low orbit, medium Earth orbit, high orbits, like that. Fine, depending on the distance. Forget about the kilometers for the time being. Low Earth orbits, many of the satellites are in low Earth orbits. There are few satellites in medium Earth orbit between 2000 kilometer and the distance later part. But you will see there are many satellites again at this distance. Why this special distance, that we will see later in this class itself. Okay, so many satellites are there in the low orbit, few are there in the medium Earth orbit, very also again in higher after in higher orbit or at this particular distance. In fact, this orbit is called geostationary orbit. Okay, in this orbit also there are many satellites. See, this is very big. The distance from the surface of the earth is this many thousands of kilometers, 35,000, around 36,000 kilometers. For the time being, you understand, around 36,000 kilometers. Again, there are many satellites. Okay, why this distribution is there, that we have to understand. Now, before going into all these things, this is the picture. We want to, through satellites are like an eye in the sky. Like an eye in the sky. We want to observe the earth, and based on that, we have to develop various applications. That is the intention ultimately. What are the applications that we will see slowly? But this is the picture we have. So much of things are there. Now, why these satellites here are not bombarding with each other? Just understand these questions. Why these satellites are not bombarding with each other? Why they are not falling onto the earth? What is maintaining that? Is there any danger that some satellites may collapse and hit us on this planet earth? Like that, various of questions can come into your mind. Okay, different paths, they are moving in their own path. It's not about own path. In road also bombardment can happen. On the road, we are on a highway, 3-lane, 2-lane, always the diversion can come. But why that is not happening, we will see. What is the basis? The main question with respect to this is, they are moving in their own path, the paths can come. So how a path is established, that we have to see. Forget about this picture for the time being. Just understand that this is Earth, planet Earth. Now I am putting a satellite in a circular orbit. This is a circle. Orbit is, what is an orbit? Path in which a satellite will go. Okay, it is a circular orbit. You understand like this. In this circular orbit, if a satellite is rotating around the Earth, why it is not falling? Because if you take a pen or if you take an object, and if you leave the object will fall on the ground. The earth will be there. Suppose you are sitting in a room. There is a table. Table is there and something is there. It will fall down. The earth will attract. Yes or no? The earth will attract. This kind of attraction is called gravitational force. What is this? Gravitational force. Okay, it's not that only earth. Any object with a mass, we are all made up of mass bodies, whether it is planets, whether it is stars or anything. Any object with a mass m will attract other mass. Mass 1, m1, m2. We are not doing physics. No IIT physics here. Just the basics we have to doing. So any mass, whether it is a pen or whether this laptop which I am speaking and me, there is a force of attraction between this laptop and me, very small. But if the object is big, like earth, like sun, that force of attraction is very high. It will pull. There is no repulsion, only attraction. Okay, so always the object will be pulled. This force is called gravity. Why that force is there? How that force is created? Nobody knows the answer. Don't do PhD. So there is a type of force which is attracting every mass. Now, when Earth is there, this is the satellite. Okay, always the satellite. Okay, we are using some rocket. Something is being done in Satish Dhawan Space Center, whatever the center, they are launching a satellite. Fine. But why the satellite is not falling onto the Earth? Anyone? Why the satellites? I said that the Earth will be attracting us. If there is a building, if you throw a stone from a building, the stone will be coming and hitting the surface of the Earth. So there is a huge pull by the Earth. Now, I said in the previous picture, all these satellites are rotating. Why they are not pulled onto the Earth? Why that is not happening? Answer? Absence of gravity you are talking, but Gravity is there. No, it's not about absence of gravity. No gravitational force. Why, my dear? Gravity is there everywhere, na? Gravity will be there. Some are saying no gravitational force. No, no, gravitational force is not very weak. It is very strong. Weak gravity because mass of Earth is in, millions of kgs. That will attract. It will attract. Gravitational force is there. Always gravity will be there. Gravitational force will be higher. Forget about weak neutron forces and all those things. Whenever there is a distance, 100 kilometers, 1 whatever there, the center of the Earth, all these distances, gravity is there. Why it is not falling? Looks like you need a conceptual understanding. One or two people are at equal to Earth speed. The satellite, no, 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 no. All these are misconceptions. One or two force of attraction cancels each other. Only one or two are clear in their understanding. See, the same phenomena is true with respect to Earth also. If we take our Earth, planet Earth, Earth is also rotating. Yes or no? This is Sun, suppose. Earth is also rotating around. This is Earth, if you can see. Earth is also rotating. Okay, why it is not falling is the force of attraction, the force of gravitation is being balanced by centrifugal force, another force. See, there is someone in between. Suppose you are there. You are standing here. You are being pulled by your brother one, let us say sister one, and you have another sister. She is also pulling you. Suppose when both of them are same together, pulling with same force, you will not move anywhere, right? Like that. Force is there. It's not that gravity is weak. No. Things got balanced. If sister one ate biryani and she got more strength, she pulled you this side. It will come this side. So whatever force is there, it is getting balanced. Now, why this force is coming? No theory is nothing. Why this force extra? See, gravitation force is there because there is sun or there is earth, whatever, depending on the context. Mass is there, gravity will be there. Bolke. Fine, but why this force is coming? Because this body, whether the earth here or the satellite, let us go to the previous picture, or the satellites here, they are moving with a velocity. When they are moving, if they stopped moving, they will fall onto the earth. Okay? If they stop moving, the earth will pull them. How much is the distance? Whether this much distance also. If they stop moving, force of gravity will be higher. This force will be cancelled. Only this force will be there. It will be dragged into the surface, into the towards the surface of the earth. Okay, so that is the understanding. With this velocity only, imagine that like this in this path. I can't show it here because it is 3D. If you see here like this velocity of the earth is creating a balance for the force, and it is able to maintain that orbit. Okay, very interestingly, this orbit is a path, whether a sun and earth, whatever is the orbit, we say Earth's orbit, like satellite orbit, we are calling Earth's orbit. Okay, this orbit need not be circular. No, it can be elliptical also. Okay, whether it can be a circular orbit or whether it can be elliptical orbit. In ellipse, this is the shape of ellipse. Okay, for all the non-science, non-max students, this is the size of a pure circle is not. What is the specialty with respect to circle? From the center, everything is equal. All are equidistant. Whereas in ellipse, you'll have two focal points. Okay, or if one sun is here, the distance from the sun will vary. Like this. Elliptical orbit. At each point, that is interesting. At each point, the force will be balanced. Attraction balanced. Okay. So when sun is, let us consider this. When sun is this only. This is where January will be there, July will be there. You know, in geography, summer solstice, winter solstice, equinoxes, all these things. Okay. So this is the month of July. This is month of July. Here, the earth is near to the sun. The distance is less. The gravitational force will be higher if it is at less distance. Technically speaking, inversely proportional to square of distance. Forget about these things. So simply put, if the earth is nearer to the sun, more force will be there. It will pull more. Okay, here more pull will be there. 4 lines like that. 3 lines, 4 lines. Here away, less pull like that. 2 lines I have drawn. So how the earth is not falling when it is being pulled here means the speed of earth here will be higher. Okay. So in a constant circle, say earth. Okay. And if you have a constant circle here, one single path, imagine this as a circle. If R, everything 10, 10, 10, 10, 10, 10 kilometers, suppose, or 100 kilometers, whatever, velocity will be only 1v. Let us say 100 meters per second, suppose. Everywhere velocity is same. Why this technicality speaking, sir? What are you talking? Are we doing physics? No, this is important for us to understand the path of the satellites. Okay, so bear for only 5 minutes. Velocity is same, but in an elliptical orbit, but when an elliptical orbit is there, velocity is not same. Okay, it will be different. Now we'll say, let us say here it is 100 meters per second, velocity, speed, forget about velocity and all those things. Let us say it's speed. Okay, 100 meters per second is the speed. Now you tell me, speed is varying because this is not circle. When it is coming nearer to the sun, the Earth's velocity here, let us say same example, let us consider here as Earth. Okay, in a circular orbit, speed is always same. In elliptical orbit, nearer to the Earth, speed will be higher. Speed will be higher than 100 meters per second. Okay, so simply put, in order to make a gist of all the things which I have talked, if in an elliptical orbit, whether it is Earth or whether it is satellite or whatever thing, if it is nearer to the center, its speed will be or velocity will be high. If it is away, speed will be less. That is the only thing which I got. That's the reason. If you look at in this figure, now analysis will come. In this reason, it has a very low speed. Very low speed. June to July to August, only this much space is required. 3 months are done. Okay, very less distance it will cover. In 3 months, only this much distance the Earth is moving. But see here, coming nearer to the Earth, only in 1 month, December to Germany, this much is covered. The same principle now, this is an example of Sun and Earth. This is Earth, na? The same thing, now you imagine at the center you have Earth. Around Earth, we have satellites. Same concept. Okay, so in this previous picture, all these things which are being sent here, all these things which are being launched into the space, all will have different, all these satellites will have different velocities. Okay, nearer to the Earth. So satellite in low Earth orbit will have higher speeds when compared to satellites in medium Earth orbit. Okay, there can be not only circular but elliptical orbits also. Like this, elliptical orbits also can be formed. Fine. Some elliptical orbits may be like this, very closer to the Earth on this side, but very far away on other side. Possible, right? Yes, they are possible. Okay, so whenever satellite is like this, more speed it will have. So more faster way we can observe the things. That is the intention here. So that's what we are telling. Now come back to forget about sun, earth, and all those things. Now come to earth, this planet. Okay. Satellites are being launched. It can be a circular orbit or it can be an elliptical orbit like this. Okay, satellites. Whenever the satellite is away, forget about these focal points and all these things, leave those things. When the satellite is away, farthest distance, that is called as technically apogee. When it is nearer, it is called perigee. It is not falling. This satellite is not falling and hitting the earth because this satellite has a velocity, because of which a balancing force will come. Okay. So this kind of, when these things are balanced, you will not. That's the reason International Space Station or anything, they will not fall because they are moving at very high speeds. Okay. So that is the thing. Things are not being fall. Now, when I can launch this what the same explanation here, forces are there. This is centripetal, centrifugal. This thing is there, not only circular. Like if you hold a string tied to a stone here, and if you move it, it is able to maintain because of this balance ball. Okay, that's what. If you cut this thread, imagine this as a stone, and you are rotating the stone. If you cut the thread, suddenly it will not fall on you. It has velocity, speed. It will go like this. Okay, that's what is being explained here. Now, when compared to Earth here, okay, so very fast, that's what I explained. Nearer to that, so this is the orbit of a satellite. This is Earth, orbit of a satellite. It can be like this also. Anyway, multiple orbits you can create. Multiple orbits you can create. It will be fixed in this particular orbit. It will be going in this orbit. So care, whenever the satellites are being launched, care will be telling that these two things will not interfere. See, all the satellites can do crossover, no doubt, but they will not reach this point at the same time. So that crash will not happen. If crash happens, they will fall onto the Earth. They will burst and suddenly orbit is changed, Earth will attract. The beauty thing is Earth has atmosphere. Earth has atmosphere surrounding it. So whenever Earth is there, it has an atmosphere around it, air. So whenever some object is falling, this atmosphere will burn it. That's what happened. Recently, Chinese satellite thought of it will come and hit some country. Fortunately, it landed in the ocean, but there is a danger actually. In spite of this burning, some pieces may be there. A big stone is enough, na? Size of a small stone, a brick size stone is enough to cause a lot of danger. Okay, so that's the reason there is always a danger, but Earth's atmosphere is going to protect us. Anyway, that's they are doing in this manner, always these things. So this is the manner satellites are being obtained. Now, I can create a satellite for us. These orbits, what is an orbit? Earth is there. Around the Earth, whatever paths you have, that path are called as orbits. Imagine this at this part you have equator. Okay, you will have equator 0° centigrade. Yes or no? This is the equator. Now the path of the Earth, suppose not the Earth, satellite. If the path of the Earth is like this, just a minute. If the path of the satellite is like this, parallel to equator. Okay, this can be a path, or it can be like this also, pole to pole. These are poles. It can be a path like this also. Like this also it can go. Understanding the path. At the center you have Earth. This is Earth. Or the satellite can roam in this orbit, or it can roam like this also. Yes or no? Different ways it can roam around the Earth. Right? It can go with some inclination like this, or here also inclination. In different ways it can rotate. Okay, so we are classifying the orbits. Okay, what type of orbits we are having, that can be classified. Classification of orbits. Okay, in that manner we can classify. If you see here, this is the broad classification which we are having. Okay, if the satellite is moving in this direction, pole to pole. This is the pole. No, of course, there's a small bending here. Forget about that inclination. If the satellite is moving in this direction from pole to pole, what pole? This North Pole, South Pole. If the satellite is moving like this, as it is moving from pole to pole, it is called as polar orbit. Okay, some kind of distinction can be said. Now, here, if it moves, forget about this particular distance. If it moves in any of the orbits parallel to the equator parallel to the equator, okay, that is called geosynchronous orbit. Some quick explanation is here needed here. If you see in the polar orbit, let us say in the polar orbit, what is a polar orbit? Earth is there. If the satellite is moving like this, pole to pole. Okay, if the Earth is moving, if the satellite is moving around the Earth like this, okay, pole to pole. This is Earth. Okay, if the satellite is moving like this, sun will be here somewhere in the solar system. Yes or no? Always sun is visible to this satellite. Yes or no? Always sun will be visible to this satellite. That's the reason polar orbit is also called as sun synchronous orbit. Okay, so always sun, always it can. How the satellite is functioning with respect to solar panels? That mean that is anyway, battery also can be there for the running of the satellites. So always it is in sync with the sun. That's the reason this pole to pole orbit is also called as sun synchronous. Okay, if the orbit is like this, if the orbit is like this, like I said, the other type, if the orbit is like this, okay, with some inclination also, anyway, it is can be like this. It is moving according, it is surrounding around the sun, around the earth. Earth is everything. So if not sun, see, if the satellite is like this, it can't be seen by the sun. Na? It can't receive sun. So this is definitely not sun synchronous. What is remaining? Earth synchronous. Earth is nothing but geo. So all these orbits in green color are called as geosynchronous orbits. Okay, so two types of orbits we did. Two types of orbits. Okay, one pole to pole, which is nothing but polar orbit, or also called as sun synchronous orbit. Other dimension is around Earth like this in this direction, which is nothing but geosynchronous orbit. So two orbits can be there. So polar orbit is also called as sun synchronous orbit. Sun, S means sun synchronous orbit. Okay, like that. Many orbits can be there, like this. Many orbits can be there. Many orbits, multiple. With some angle also they can be launched. Fine. This is geosynchronous orbit, this direction. Geosynchronous orbit is also called, or geosynchronous Earth orbit, whatever the general names you have. There is one speciality with respect to geosynchronous orbit. One speciality. What is that specialty is, if the distance from the Earth, the surface of the Earth is around 36,000 kilometers or 35,786, the period, the time this satellite takes to rotate around the Earth is exactly 24 hours at this particular distance. Okay. So what is the period of rotation of Earth? 24 hours. That is matching with this, only at this distance. Because if the distance changes, velocity of the satellite changes, speed changes, so time also will change. So the time taken for one complete revolution of this satellite at this particular distance is equal to 24 hours. Same like rotation of the Earth, one rotation of the Earth. Why so much speciality to this one distance? Why so much of importance we are giving to this thing is, the specialty is it will appear as if the satellite is stationary. Suppose we are launching the satellite, at this particular distance. That is parallel, that is in geostationary thing. Na? If the distance is around 36,000 kilometer and you have launched from India, you can see that the satellite, in spite of moving, it will see as if it is somewhere being fixed in the sky. It is stationary, as if someone fixed it in the sky. Because this speed equal to this rotation, revolution. It will appear as if it is located there as a fixed point and it is continuously observing us, India or USA accordingly. Different positions you can make. That's the reason it will appear. It is moving just like two trains moving. There are two trains side by side moving at the same speed. Okay, person in both trains will feel that both trains are stationary. That means there is no movement like that. Two trains are similarly, it is happening like that's the reason this one particular orbit is called geostationary orbit. So geostationary orbit is a special case of geosynchronous orbit. Okay, so that is the things which we have to understand. Now, like you have two types of orbits. Now you want Telugu. Okay. Somewhat Telugu, technical orbit Telugu, equator. Somewhere you can ask me at the end if you are in any discomfort, unable to understand, you can always ask me. Don't worry. తర్వాత అడగండి ఏమన్నా ప్రాబ్లం ఉంటే. చూద్దాం. ఇప్పుడు ఈ కంటెక్స్ట్ లో like we are having broad classification. Once you understand this, it will become simple. You have two types of orbits. Yes or no? Polar or sun synchronous, then geosynchronous. Okay, two types of orbit. Similarly, you have two types of satellites. Based on this only, two types of satellites broadly. Similarly, you have two types of launch vehicles. What is a launch vehicle? How these satellites are going here? How these satellites are being established? Bahubali will come and throw here. No. There is a rocket launched. Okay, it will have a payload. They have different rockets. It will have fuel. And here you will have satellite. Okay, rocket will take it. All the stages will be there. Solid, liquid, 4 stages. Various launch vehicles you have. They will take everything. All the parts will be detached. Finally, when it reaches the orbit, only satellite will be there. It will be launched there and it will orbit. So these rockets are which are called as launch vehicles, which will carry satellites into space, into orbits or space or orbits. There are also two types. Okay, just by orbit classification, we are simplifying everything. That's what it is done. So two types of orbits. Okay, two types of orbits, two types of satellites, which are called as communication. I will tell these things in detail. Communication satellites and Earth observation satellites. Earth observation satellites. These are the two types. Similarly, two types of launch vehicles. This type we are talking in context of India. Forget about USA. It has a different system. In India, we are classifying all these classifications in respect to India. Two types of launch vehicles. Polar satellite launch vehicle. Polar satellite, as the name says, it's a satellite launch vehicle. Launch vehicle, simply saying. Similarly, pole means it will generally go, don't assume, generally for polar orbits. Geosynchronous launch vehicle. GSLV. Geostationary or geosynchronous satellite launch vehicle. Two types. Okay, type 1, type 2, depending on the type of orbits which you have to think. Okay, so polar satellite, geosynchronous, I am not saying that all are parallel here. Polar is polar, we will see where communication satellites are launched. Don't get confused here. I might have changed these things here. That anyway you will know later. So generally this is the case. Okay, this is the case which I will tell in detail later. Fine. Now we will see type of satellites. Draw these things. Well, forget about, don't link them parallelly. Don't link this parallelly. Only write two types of satellites, two types of orbits, two types of satellites, two types of launch vehicles. What is what we will see. What is what we will see slowly. Okay. This time. Till here, any doubts you have? Any doubt? Anyone? అందరికీ అర్థమైందా? Someone has raised the hand. Let's see. You want to ask something, Shruti? I have unmuted you. Yes. ठीक है. Fine. बहुत बढ़िया. अब जल्दी चलेंगे. So, geostationary and geosynchronous, see my dear, if you look at the orbits here, one special case of geosynchronous, there can be many geosynchronous orbits, different distances can be there. One special case of geosynchronous, only one special case of geosynchronous where it is at a distance of around 36,000 kilometers is an example of geostationary. Why only such importance to such one distance? Because it is as if it is observing, as if it is staying. So we can have a satellite on India continuously looking at India without moving anywhere. That is the speciality of geostationary. That's the reason in the first picture which we saw, lot of applications are there with respect to this kind of orbit. Many people, many countries launched all these satellites because for them it will appear constantly. Small distance. Many people, many here also, apart from LEO, here also many satellites will be launched. Most in demand. There is only one orbit. So in the future, people may fight for that. People may fight for that orbit. If more kinds of satellites are being launched. In fact, that is a danger in the future. Okay. So that's what we are going to look into it. Now, if you look at, I'm taking away these things. Imagine that, remember that all two types are there broadly. Now, first kind of satellites which we have to look here is communication satellites. Now you understood the basics, we can move somewhat easily. Listen, first kind of satellites here is communication satellites. In communication satellites, one type of is communication. Communication satellites, look at the applications basically. Types of satellites are depending on how they are used for us or how they are useful for us. For us purpose only, na? Basically why we are launching space program, so that we can use for various applications. Yes or no? That is the intention of taking so much of risk and sending the satellites outside into the space. We want to use them for varieties of applications. Okay. So a controversy has emerged initially when in 1970s, 1980s, where India has still various challenges of poverty, illiteracy, all these problems are there. Why India has to invest in space? That is a question they asked. Why you have to invest? Even today there is a question. Even now today we have poverty. Then why we have to launch Chandrayaan? First, look at our lot of people who are there without food, without education, without group 1 job. So when you have so much of problems, why you want to do something in space, which is generally the area of developed worlds? Developed people have a lot of self-sufficiency in many things. Now they can explore space. They can question why universe is there, how universe got created. They can do all the research. So it's not that me saying this. Initially, that was the question they were posed. Why we have to invest in space when you have so many of problems? Even today, there is such question in some aspects, not all. Why India has to do Mangalyaan? Why India has to do Chandrayaan? Okay, satellites, none we understood. First of all, in the first part, we'll understand the first part. Why in 1970s? Because at that point of time, USSR and USA are fighting for space race. Okay, who will launch the satellite first? Who will go to the moon first? All is a race between these two countries. So why we have to interfere in that thing, Bolki? It was questioned. No, Vikram Sarabhai and all the scientists, eminent scientists, they clearly said that no, we have to develop applications for varieties of things. Not only communications, not only mobile phones, not only weather reports, we have to monsoon reports, disaster management. Varieties of applications are being developed for the use of various cross sections of society. Fishermen will get to where fishers are because of satellites. Even today, look at, imagine, without GPS, can we go anywhere? To locate an institute, to go to locate a pizza house, everywhere we are using GPS. Without satellites, is this possible? No. So we developed our own version, India's own regional navigation system, rather than depending on GPS. GPS belongs to USA. Okay, rather than depending on a foreign country, now we developed this. So varieties of applications can be developed. Similarly, types of satellites based on types of applications they are used. So communication satellites are used, as the name says, telecommunications, television broadcasting, news gathering, various societal applications, weather forecasting, disaster warning, search and rescue operations. These are the broad qualifications for applications for communication satellites. So which of the following are the applications of communication satellites? A, B, C, D, E. That can be the question. Okay. So like this, they are there. India has INSAT and GSAT series. So wherever you have INSAT and GSAT, satellites are like you have names, satellites are also having names. So INSAT and GSAT series are generally which type of satellites? Communication satellites. Many satellites are launched actually. Then another type of satellite which we have is Earth observation satellites. Okay, this type of satellites are called Earth observation satellites. Not a doubt here. Yeah, near to equator. Biswas ji, how can Pavan? How can a satellite maintain its speed in a particular orbit? Because see, what is one of your friend is asking, how can there is no fixed speed. If it is only elliptical orbit, your friend is asking, the Earth here, okay, how can it maintain a speed? That's what, na? We are above the atmosphere. Above the atmosphere, there is no air friction. Now, once we launch with the velocity v, there is no one to reduce the speed. It will remain at that v only. There is no friction, na? Okay. If air is there, air will stop it. Reduce the speed. And if the speed is reduced, slowly the satellite will come and hit the earth. Boom. But there is no one to reduce the speed. Atmosphere is nahi. Friction is nahi. Nothing is there. Okay. In fact, at that, if you surface of the earth, only up to 10 kilometers you will have just below the troposphere. You will have atmosphere. Above it, it is very less density. We are talking about hundreds of kilometers. Okay. That's the reason the speed will be maintained. Understood? Yeah. That is the thing. Not complete vacuum also. Friction is very less because for a few hundred kilometers, you have some kind of light atmosphere. Okay. Now, second type of satellite is Earth observation satellite. Several applications, agriculture, we are observing the Earth. Okay, this is also called as remote sensing satellites. This terminology is important. The second application is also called as remote sensing satellites. For knowing agriculture, which crops are grown in which districts, cropping pattern, water resources, urban planning, roads, rural development, mineral resources, natural resources, okay, ocean resources inside, disaster management. One or two may be common, But the majority of the applications, you see there is a difference. What is the difference? That is important. Communication satellites, they will provide you a link. Your phone is there. You will call your friend. Hello, Chinna Munna Bolke. It will take the signal and send it. Okay, so it has to maintain that site. That's the reason communication satellites, generally they will be stationary. Generally, don't conclude it. So most of the communication satellites will be launched in which orbit? Geostationary orbit. Generally, exceptions will be there. Okay, that's the reason all the DTH, direct to home. What happens in direct to home if Airtel or Star Network or Tata Sky, if you go and observe, the television data is directly coming from the satellite. Okay, previously in cable connection, only one big antenna will be there in a particular village. One big antenna will be, it will receive and it will go us through cables. Okay, now you look at our direct to home, satellite is directly providing the link to our homes. That's the reason when rain happens, cloud comes in between, you will not receive signal. Okay, and if you see all the Airtel or the Airtel small dishes or the Airtel Tata dishes will be in only in one direction. All the Tata Sky, they will be in different direction, but different direction when compared to Airtel. But all Tata Skies will be in particular same direction. This will be looking at north maybe. This will be looking at south. But all Tata Skies, if you see, they are looking at the same angle. All Tata Sky dishes on your side upper on your apartment will be looking at in the same direction. All Airtel in somewhat different. Some angle will be there like that. Directly the satellite is there. So communication satellites, that observation, continuous observation should be there. Whereas Earth observation satellites or remote sensing satellites, they have to survey the Earth again and again and again and again and again, and search for resources, search for environmental issues, search for urban planning. Continuous mapping has to be done. So generally, Earth observation satellites or remote sensing satellites are launched in polar orbit, whereas communication satellites are launched in geosynchronous, mostly geostationary. Okay, so that is the difference. Now you got. Similarly, so India has its own things. I will try to conclude here in some time because next class will be there. So Earth observation satellites, these are the various applications. Remote sensing satellites, which are all Earth observation IRS series, we are also calling as Earth observation, are also called as in India remote sensing satellites. Okay, they are generally in sun synchronous, which is nothing but polar orbit. That is a general classification. So these are the various examples how airlines are going through Gagan. Gagan system is there only to guide the airlines. All these are the applications of Earth observation satellites. GPS, Gagan, IRNSS, India's own regional navigation system like GPS, which is also called as NAVIC. All these are the examples of which type of satellites? Earth observation satellites or remote sensing satellites. Okay, a very broad classification. Now, third point, I said 3 points when we are discussing orbits, satellite, third, launch vehicles. Yes or no? Same manner here, or now it comes to launch vehicles in India. Forget about the historical developments, all the theories. It started with SLV, satellite launch vehicle, then advanced sat vehicle, PSLV, GSLV, and all these things. We are talking about these two. Leave the past. Now we have two major things, PSLV and DSLV. These are upgraded versions, Mark II, Mark III, size will be different like that. In details, we will see. So PSLV satellites are generally used for polar things, but they can be used for other orbit also. So PSLV is called workhorse of ISRO. What is ISRO? Indian Space Research Organization, main entity. Because Around 47 launches or 48 launches, 43, 44 successful launches are being done by PSLV. The correct number we can see, I'll display it later. So only 3-4 failure rates. So it is the best application, that too at the cheaper cost when compared to other nations of the world. We are able to launch satellites into the orbits at a very less cost. If USA spends 10,000 crores, we are able to do it in 1,000 or 500 crores only. So through PSLV, low cost, cheapest technology, we are able to launch satellites. This PSLV can be launched for both, very interestingly, sun synchronous and geosynchronous orbits. Both are being used. Don't say that PSLV, because we are so much dependent. This is GSLV is a new addition. For 20 years, we are almost dependent on PSLV. That's the reason PSLV is used for both polar orbit or sun synchronous as well as geostationary synchronous transfer orbit or geosynchronous orbit for the time being. It is used for both launches. GSLV will be used, obviously, as the name says, geosynchronous satellite launch vehicle only for geosynchronous orbits. Okay, so we are heavily dependent on PSLV even today. So this is the broad classification of we are doing different stages in these launch vehicles. All these things we will see tomorrow. Now, one question we will conclude it. Why this generally the satellite launch vehicle in India? We have Sriharikota, Andhra Pradesh, near Nellore. Sriharikota is the launch pad. In USA, Florida, in French Guiana, this is the place where it is satellite launch generally there. Why most of the satellite launching pads are located on near to equator? Where is the equator? Here through it is passed. Na? They are very near to the equator. Okay, and they are located on east side. All are located on east side, near to equator, on east side. Why this thing is happening that you think? I don't want to stop here itself because I thought of going. So ISRO, these are the ISRO centers. I'll answer this question tomorrow. Why it is like that? That we will answer. I want you to think by that time. This is Indian Space Research Organization. It has established so many centers. Should we remember all? No. Briefly see once. We will see it briefly. We'll conclude now. I want to show one thing. So it has developed so much of infrastructure. That's the reason space, nuclear, defense. These three are the very strong areas with respect to India. So much of infrastructure they have developed. That too from very early stage. Okay. So this is only about ISRO Space Center. We will see these things in detail tomorrow. Master control facilities, deep space network, Vikram Sarabhai. That thing is there. I purposely stopped these things. I will discuss these things tomorrow. One thing I want to write this question. Discuss the contribution of Indian space program. See, I didn't tell the details of the space. What main things only you have to know 3 things. So why we are developing space program? That is the question which I want you to try. How space program has contributed for socio-economic development of the country. What did we get out of space program? General question which we can write. Okay, so write this thing. Students who have taken admission, they can send this answer to me as a PDF. I will correct it and post the comments directly to you personally. We'll create a group soon, so others also can practice it. Students who have taken admission, for them definitely I will correct and send it tomorrow itself. Okay, so write this question. Try to write this question. I will anyway discuss this question tomorrow. I want you to try. What is a generally, sir? Don't think that that thing is covered. No. How space has benefited the nation? What are the benefits? How socio-economic development means it's a very general term. Na? So how space program has benefited us? Like that, 10 marker answer. You try. Students who have taken admission, definitely I know their names. You have to write and send me. Okay, that is the thing. Anyone would like to ask any doubt? Someone raise a hand. Type this. I'm unable to see who I think. Yeah. That's it for today. Fatima, you would like to talk something? I have given permission to unmute. Okay, fine then. So if you would like to join, the links are already posted in the Telegram group. Accordingly, you can. Fine. So we'll meet tomorrow. Bye.